Okay, so good day everyone. So this is still under statics of rigid bodies. So last time we have finished discussing the reduction of a simple distributed loading. So meron lang akong i-clarify doon sa yung first example natin. So yung sa first example natin na triangular loading. Okay, so di ba given nakakuan pala siya. Given na function is pressure, so 800x so Pascal, 800x Pascal, and then meron tayong width dito, if I'm not mistaken, it's 0.2 meters. So ang length nito is 9 meters. So clarify ko lang yung x natin is actually x, ang length natin ng length ng beam natin is denote natin as a function of x. No? So when x equals to 0, so at this point, x equals to 0, at x equals to 0, the 800x magiging 0 yan. Diba? And then at x equals to 9 meters, so magiging 800 times 9, so you will have the 7,200 Pascal. So that's why you see in the example na may nakalagay na 7,200 Pascal dito. Okay, so it was obtained by this function or through this function. From this function, I mean. So 800x. Okay? So baka ang pagkaintindi natin is kasi yung x doon is hanggang dyan lang. So this is our x. No. It's the distance here is a function of x. So yun lang yung i-clarify ko sa last na discussion. Okay, so this time we are in the chapter 5, equilibrium of rigid body. And if you still remember, may natapos tayo na chapter which is equilibrium of a particle. No? And in that chapter, nasabi natin that a particle is said to be in equilibrium if it remains at rest, if originally at rest. And to maintain equilibrium, it is necessary to satisfy Newton's first law of motion, which requires that the resultant force acting on a particle to be equal to 0. So mathematically, that is expressed as the summation of all the forces acting on the particle should be equal to 0 for it to be in equilibrium. For it to remain in static equilibrium. Yun yung concern natin, yung object remains at rest. Now, ano pala yung ibig sabihin if our resultant is non-zero? So what if our summation or the resultant force is not equal to 0? Of course, hindi na siya in equilibrium. Hindi na. It will not be in equilibrium. And what will happen is your particle, if that's a particle, or your body, if that's a body, will move in the direction of the resultant force. If this is our body, meron siyang resultant force na Fr, so non-zero. So this body will start moving in the direction of the resultant force. And hindi siya mag-move in a way na constant yung velocity, but it's going to accelerate in this direction. Okay? So yun yung ibig sabihin if our resultant force is not equal to 0. So hindi siya in equilibrium. Now this time, from equilibrium of a particle, we will move on to equilibrium of a rigid body. So chapter objectives: to develop the equations of equilibrium for a rigid body, to introduce the concept of the free body diagram for a rigid body, and to show how to solve rigid equilibrium problems using the equations of equilibrium. Okay. So, suppose we have here a body, eto, at figure A, that is subjected to an external force and couple moment system. So we have here the external forces, F1, F2, F3, F4, and then meron tayong couples, no? So we have M2 and M1. Now, we have learned in our previous discussions na may mga method na pwede tayong gamitin para ma-simplify yung isang force and couple system into a simpler form or system, which is isang resultant lang and isang resultant force lang and isang resultant moment couple. Okay? So, di ba na-learn natin yun last time. Now, if the resultant force is equals to 0, and at the same time, the resultant moment couple is equals to 0, ang mangyayari, our body, if ma-meet yung criteria na yan, if ma-meet yung dalawang to, our body is said to be in equilibrium. Okay? Our body is said to be in equilibrium. So mathematically, that would be expressed in this way. Fr equals to summation of F equals to 0. And MRO is equal to summation of MO equals to 0. So ano ba yan? So in this first equation, the sum of all the forces acting on the body is equal to 0. And in the second equation, it means that the sum of the moments of all the forces in the system about point O. Okay? So the sum of the moments of all the forces about point O, i-add natin sa mga couple moments kapag ang sum is 0. So together with this first condition, the body will be in equilibrium. Now these two equations is necessary and sufficient. Necessary and sufficient for equilibrium. Necessary and sufficient for equilibrium. Okay. Now, when applying the equations of equilibrium, i-assume natin that the body remains rigid. Again, in reality, however, lahat ng bodies, they actually may deform when subjected to loads. Although this is the case, most engineering materials, such as yung steel and concrete, they are very rigid, and so their deformation is usually very small, so we can consider them as a rigid body. Okay, so therefore, when applying the equations of equilibrium, we can generally assume that the body will remain rigid and do not deform under the applied load without introducing any significant error. This way, the direction of the applied forces under moment arms with respect to a fixed reference magre-remain pa rin yan remain unchanged before and after the body is loaded. So, now in the first part of this chapter, we will be considering a case where the force system on a rigid body, when the force system acting on a rigid body lies on a single plane, we will start dealing with this kind of force system, lies on a single plane o di kaya may be projected onto a single plane. May be projected onto a single plane. And furthermore, since coplanar na siya, na nakalay lang yung forces in a single plane or na-project natin in a single plane, yung mga couple moments natin acting on this plane, for sure, they will be directed perpendicular to this plane. So it's either into the plane or out of the plane. So this kind of cases of force system, we refer to it as two-dimensional or coplanar force system. Now, if we consider that this two-dimensional or coplanar force system is in equilibrium, so thus we say that this is an equilibrium in two dimensions. So such as this one, class, example nito is etong airplane. So etong airplane, if you look at it sa front view dito, you will see that meron siyang plane of symmetry. So pwede natin siyang i-cut sa center axis, and then you will see that symmetrical lang naman siya. No, everything to the left is the same lang to the right of this plane center of axis. So we can actually project the forces acting on this plane in isang plane lang. So ito, as you can see. So if we project it in this plane, ditong sa side view niya, so as you can see, the forces acting on this plane is yung weight of the plane. And then, meron siyang wheels. So sa front wheel, isa lang siya. So i-denote natin as R, yung reaction of the ground to that wheel or the normal force. And then eto naman dito na part, dalawang wheels yan. So merong sa left and meron sa right. But since we projected it into a single plane, if each wheel merong reaction na T, yung sa right and sa left T. So therefore, when we projected it into this single plane, we can actually refer to the reaction as 2T. No? To account also the other wheel on the left side. So this is now two-dimensional or coplanar force system. But originally, hindi. Gi-project lang natin siya. So pwede yun mangyari if you know how to project. Okay, next. It will be the first step actually in using the equations of equilibrium, kailangan natin munang i-draw yung free body diagram ng body. Okay? So we need to know how to draw the FBD. No? This is to account for all the forces that is acting, external forces that is acting on the body. Kasi if sa first step pa lang, mali na yung FBD mo, so kahit ginamitan mo siya ng tamang equilibrium equations, you will still arrive with the wrong answer or conclusion. So a free body diagram is a fundamental step in solving equilibrium problems. So we have also discussed how to draw FBD in the previous chapter, sa chapter 3 or chapter 2 ba yun, yung equilibrium of a particle. And also you have dealt with that in your physics na subject. So you must review how to properly draw the free body diagram and what forces to account for. Okay, so I'll cut this video and then make another one for the continuation. So